Hello and welcome to today's physics class. For this class, we look at the concept of calculation based on magnetic field. So in our last two classes, we dealt with the introduction to magnetic field, and also I derived several formula to magnetic field. Right? We have like two formulas. So those two formula have their vector forms, right? Which I've given you guys in our last two class. If you have missed the videos on our last two class on magnetic field, I'll drop two links in this video description. So check this video description. You see two links that will take you back to our previous classes. So as someone new to this topic, don't just jump down to the calculations. Try to understand the foundation. So I'll drop the link to the foundation in this video description. So do well to check that first. After understanding the foundation, then you can now dive into the calculation based on magnetic field. This class will look at just three good examples to understand how you can apply those formulas we have learned in the last class in solving problems involving the concept of magnetic field. Let's first, I'd like to do a recall on these formulas. So we established that when it comes to magnetic field, that there are two distinct formula we use in this case. The first one there is given that F is equal to what there ILB sine theta, right? And we said for this first formula here that the vector form for this first formula, the vector form for this first formula is given as F, right, is equal to I L cross product of B. Of course, if I want to, I can attach, of course, sine theta here. So we establish this as being the vectorial form of writing this first formula as shown on the board, right? Next up there, we also established that the other formula is given by F equal to QVB. If I want to, I can attach sine theta. Last class, I explained that adding sine theta or perhaps attaching sine theta has a condition. If you are given a question whereby you have an angle in the question, in that case there, you can attach sine theta. It is optional. If you have a problem whereby theta is mentioned, then you apply what there, you bring in sine theta concept. But in the case where you don't have theta, then you have to what there, ignore it. So this one, second formula here, in vectorial form, this given has vector form is equal to what there, Q, of course, V cross B in this form, of course. If I want to, I have sine theta. These are the two formulas we learned last class, right? When we say I is your Tesla, right? Your magnet Tesla. L is your length. Sorry. I is your current per se in ampere. We said L is your length in meters, and B is your bar magnet, of course, measured in Tesla, right? So Q is a charge here. I would say this Q has a constant value. I gave you the constant value last class, that Q has its own constant value, and I gave you the constant value last class. So let me just recall you guys so that Q, don't forget please, Q is equal to negative 1.6 times 10 to the power of minus 19, right? Coulomb, because it's charge, and charge is measured in coulomb, right? As you can see, the stuff here. All right, and V here is of course your voltage, right? Your voltage. I've explained B from here. So this is like the revision we can actually do based on what you have done so far in the last class. So let's, with this few concepts, let's try to solve some past questions in the study of magnetic field. All right, sample problem one, sample problem one. All right. So let's take example one. In this case, example one. It says find the magnitude of the magnetic force on the 100 mm length of wire strain between two poles carrying a current of 250 ampere. First stop. It says the Earth's magnetic field makes an angle of 60 degrees with the wire. Take B, which is the bar magnet, to be 5 times 10 to the power of minus 5 Tesla. So first things first, this is a science question. I said when it comes to a problem involving science, your first task is that after reading that question, you should work there, list out your given parameters. So in that case now, let's look at the givens. All right. So they said says find the magnetic field magnitude of the magnetic force. So I'm looking for F. Of course, magnetic force, magnetic force. Of course, that's the F. So we are looking for F. Moving on there, it says on a 100 meter length. So the length given, length, of course, L is of course 100 meters. Moving on with this, then it says of wire strained between two poles carrying a current. Of course, we're given current. That's I. Current, of course, that's I. That's of course 250 ampere. All right. So current is measured in ampere, as you can see. So moving on with this, it says the Earth's magnetic field makes an angle of what there 60 degrees. So we have an angle. Theta is given in this case. So theta is of course 60 degrees. Finally, we are given that B, which is called the bar magnet, of course, has been equal to 5 times 10 to the power of negative 5 Tesla. All right. So bar magnet is better than what the in Tesla. These are what we are given, right? So we are asked to find our force here. Now, looking at these two formulas, I have two formulas. By the way, first things first, before I determine, because I can say we have this in four cases. This one, two, three, four. Four formulas here. So which one am I to use? First things first, I can use this vector form, this and this. I can use it. Why? Because there's nothing like I and J here. Everything here is in scalar form, not in vector form. I'm not getting I and J. So I and J comes in. So if I say the word I and J, then I will apply what the vector form formulas. But there's no I and J concept here. So I'm going with what the normal form, the basic form. So within this and this, one of them will be the exact formula to apply here. And which one I'm applying, of course, is clear. This parameter here, I'm looking for force, right? But I'm given length, current, and magnetic bar magnet. So in this case here, if you check the second formula here, the second formula, I'm having voltage and charge. There's nothing like voltage and charge here. So this one here, I can't use this. So the proper formula to use here is this first one here, that is equal to F equal to what there? ILB sine theta. And in this case, I'm attaching sine theta. Why? Because I'm given angle as what there 60 degrees. So at this junction here, I will recall. So recall that we established earlier that force, which is the magnetic force, is equal to what there? ILB, of course, sine theta. So from here, I'll have that F is equal to what's I? It's clear. I is 250, so that gives you 250. All right. Into what's L? That's 100. I have 100 into what's B? Bar magnet. That's this value here. That's 5 times to the power of minus 5. Of course, don't forget we have center left. All right, let me take this off. So I have sine theta is of course 60. That gives sine 60 degrees. Punching my calculator, what do I get here? The F, which is the what? The magnetic force is equal to, I'll multiply 250 by 100. That will give me 25000. That's more like 12,000. So don't forget I have this one, these two left. Into 5 times 10 to the power minus 5. Of course, 1 sin 60. My calculator. My calculator from here. Come in. Sin 60. Um, of course, in brackets, sin 60 is what? That will give about sin 60. That's 0.866. Okay, 0.866. From here, multiply this with this value. Yeah. So I have that f is equal to, if I want to multiply this with this and with this, my final answer here my force becomes 1.08 Newton. So my force, which is magnetic force, right, is equal to what there? 1.08 Newton. Of course, force is measured in Newton. So my answer becomes 1.08 Newton. This is how you solve question based on magnetic field, as you can see on the board. This first example in the study of magnetic field. Let's take yet another example to better understand the concept behind magnetic field. Welcome back. Let's take example 2 in the study of magnetic field. In this case, I'll include the idea of IJK, that's like the vector form. So cell can play with vector form of magnetic pattern, right? So let's take an example. It says the magnetic field B over a certain region is, in brackets, 4I minus 11J Tesla, that's T, comma, an electron moves in the field with a velocity of v to be equal to negative 2I plus 3J minus 7K meter per second. It says, what is the magnetic force? So we are asked to find F in this case. What do you do? Your very first task in this case is to list out the given parameters, right? What are you given? So from the givens there, we can actually find the value of what's force, right? So my very first task here is that I'll take problem 2. So we are given that a magnetic field B. So I'm given B Tesla to be done. Coming problem 2. So I given B, of course, in vector form, because that value was in vector form. That's IJK concept, right? B to be equal to 4I, sorry, 4I, of course, minus 11J. That was the value given for B. We also have the velocity V also was given in vector form, and the value is of course is equal to 2I plus 3J, of course, minus 7K. This stuff here, this one here is in Tesla. This one here is in meter per seconds. Why? Velocity. All right, I'm given these two stuff here. Moving on, if you check properly, I'm also given the value of, hold on. I'm given value of, okay, that's the only two I'm given. Okay, that's what I'm given. That's what I'm given, please. All right, in this case, now look up, please. In this case, I'm just given only two things given. I'm given B and V. It is clear. This stuff here is a vector form. So it means this and this cannot be applicable in this case. It's fine. But I'm left with what? Two things now that can apply here. This one here and this one. So which one best fits this approach to solve this problem? Which one best fits? It's easy. I'm given B and B. Of course, I can say B, but there's no V. Sorry, I can see B here, which is this, but there is not V. V is not here. So it means this one can't work. It can't work. So I have to check on for this. You can see I'm seeing B, I'm seeing V. So it means that I'm using this formula to solve this problem. So just find this formula out, right, and use them. Just check into your parameters, and then you can detect which one best fits solve your problem. All right, I'm using this one here. So I have to recall, right? I have to recall that we said, recall that we established earlier that force that we're looking for in this case is equal to what there? Of course, Q V vector form cross B in vector form, of course, sin theta. In this case, am I adding sin theta? Yes or no? Of course, no. Why? Because nothing like angle was mentioned in this case. If angle was mentioned, of course, I'll add sin theta to the end of this problem. First things first, we need to know these things. We need to know to find F easily. We need three things to be known. Number one, we need to know Q. Number two, V and B. Obviously, we are given Q already as a constant. So Q is equal to what there? Negative 1.6. That's to the power of what? Minus 19 coulomb. That is value of Q. And Q, of course, is a constant term. Q, of course, is a what that is a constant term. So how do I go about solving this problem? It's easy as my first priority here is that coming. My first priority here. All right. So my first priority here is that if you observe very well. If you check your B, my B obviously is meant to be given in IJK, but I'm given high J. There's no K. It means K is 0. For V, I'm given IJK complete, right? So I'm asked to find F, which is the force, the magnetic force, right? So my very first task is that I have magnetic force F, my F to be equal to, of course, I can say Q first. So my Q is a constant value, that's negative 1.6. That's the power of what? Minus 19. That's value of Q. Done. Next up now, I have V minus of V cross B. This is an idea on that vector. So I will advise you to watch our video on cross vector. I've done a video about scalar vector and scalar vector. Yes, scalar vector, right? That's a type of vector, right? We have the scalar and the type of vectors, right? So I've done a video on how to, hey, yes, we have the dot product vector and the cross product vector. In this case here, I'm having cross product vector. So when I have cross product vector, what do you do in this case? It's simple as you apply the idea of determinant of a function, like determinants, matrix and determinants, right? So in a case like this, when I have V and B, obviously we said this B can also be expressed as 4I minus 11J plus 0K, because there is no K, so I can put 0K. 0K means nothing, right? So just make sure that everything rhymes. IJK, IJK. It means that I'm going to be having this. So I'm going to apply a matrix concept in this case. So I have I, J, K. We said a matrix put plus minus plus concept, as we said um, before now. So for my V, I have 2, 3, 7. That gives you I. For V, my I is 2. For V, my J is plus 3. And for V, my K is minus 7. So I have minus 7 here. Of course, moving on, for my V, that my what's it called, magnetic field, right? I have that I is 4, my I is 4, J is minus 11, and then K is of course 0. So with this here, I can apply matrix concept to solve this problem easily. From here, I'll keep pending. All right, from here, I'll keep pending this. I'll repeat this down. I'll try to work on this, right? Alone. Let's work on this alone and then bring back this. If you go back to mathematics, when you have this concept, what's the first priority? Is to bring out your positive I. So bring out plus I. So I have to work on this alone, right? So I'll pen this to work on this alone. I'll have plus I, right? Of course, my determinant this way. If I take a plus I, so it means I'll cover the row and column of I. What do I have left? I have 3 minus 7 minus 11 and 0. So I'll have 3, 3 minus 7, right? Minus 11 and 0. That's plus of I. Moving to minus j. So I move to minus j minus j. So minus j there, it's simple as if I take in minus j, cover this place and cover this place here, I'll have 2, 4 minus 7 and 0. 2, 4, that's 2, 4, sorry, 2, 4 minus 7 and 0. So minus 7 and 0. That's for j. Go to k plus k. For plus k, I'll have close here and here up. So I have this 2, 3, 4 minus 11 left. That's 2, 3, 4 minus 11. All right. This is how you solve this particular portion here. I'll try to break this as soon as I can. So let's move on with solving these things. Moving on here. All right, take this down. Take this off. Wait, is it recording? All right. So from here, I'm going to apply what we called what's it called? We apply the concept of, I can't remember the English very well, but I can still recall the concept, right? I'll apply what called what is the English here? All right, I can't remember very well, but let's visualize. Let's visualize. So from here, I want to break this down further. So this gives you plus I, of course. Mind you, I still have these two left. I just want to break this one down because of the side of the board, right? So this gives you plus I, right? Into, we said multiply your diagonal ahead. That's English here. Diagonal matrix together. So minus 7 times minus 11, that gives you plus 77. That gives 77, right? Plus 3 times 0 gives you 0. All right, I have this. Observe what I did earlier, right? All right. So I said minus 7 times minus 11, that gives you plus 77. I have it here. Moving on, plus 3 times 0 gives you 0. I have my 0 here. I have minus j, so that gives you minus j into multiply diagonal matrix. So this one here, minus 7 times 4, that gives you minus 27, sorry, minus 28, right? 2 times 0 gives you 0, that gives you plus 0. All right, plus k, that gives you plus k into 3 times 4 gives you 12 plus, sorry, is minus per se, please. Is minus, you're subtracting, right? Subtracting, please. I'm sorry. You're subtracting. When you multiply diagonal, subtract from what? This other one here. Multiply this with this. That answers. Subtract away from the other one here. So 3 times 4 gives you 12 minus 2 times minus 11 gives you, of course, minus 22. Minus 22. Right? Moving on here, this gives you obviously 77 minus 0 gives 77. That gives 77 I, right? From here. So 7I, then minus 28 minus 0, that gives you, so plus minus gives you plus, right? 28 minus 0 gives 28, that gives you 28j, right? Of course, plus minus gives you plus, so 12 plus 22, that gives you 34, that gives you plus 34 K, right? So when I solve this one here, I have this value as my expression, right? So moving on, it means that coming back here, I'll have that F is equal to this value here. That's 1.6 times 10 to the power what there minus 19. This one here into everything here now comes down to this, right? Yeah, come down to this place. So that gives you about working on this. I'll have 77I plus 28J plus 34K, right? So I'm going to pick out this, multiply it with this, pick out this, multiply it with this, pick out this, multiply it with this. That is my next task here, obviously. So to move on with this, so obviously I'll multiply them together. So multiply 77 by this, right? And then this 28 by this value, and then that's 34 by this value. So it means that my F will be equal to of course, coming calculator. I'm going to multiply 77 by this value. So 1.6 times 10 to the power of 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 coming minus 19, right? So multiply by 77 times 77. That gives about 1.238 232 1.232 times 10 to the power of what? Minus 17I. I'm done with this. So moving on, plus 28 times this value. So that gives you that this value here times 28. That gives you 4.48 times 10 to the power of what? Minus 18. This is J. Alright, plus multiply this time our value here by 34. That gives 5.44. Alright, we call it principal diagonal. We call this principal diagonal. So minus 7 minus 11. This stuff is called principal diagonal. That's the English place. So moving on here, I'll multiply this value 34 with this expression here. That gives 5.44 times to the power of what? Minus 18. Of course, that's K. So this is my value of my force, of course, in Newton. So I'll update this in brackets, of course, in Newton. This is how I get this question. That I solve this problem in the study of magnetic field, as you can see on the board, right? Alright guys, so the last example, I won't solve the last example, right? I'll give an assignment. So it says an electron experiences the greatest force at its travels at 3.9 to the power 5 meter per second through a magnetic field. When it is moving westward, the force is upward and has a magnitude of 8.2 times 13 Newton. What are the magnitude and direction of the magnetic force? Sorry, magnetic field per se. So listen to this. Let me give you an idea behind this question, right? So the formula you're using here is that F equal to QVB sin theta, right? And then I'm attaching sin theta because it says an electron experience the greatest force. So if you check our last very first class we did, we said that magnetic force will be greater when what? Theta is 90 degrees. So my theta here in this case what is 90 degrees. Why? Because my force is at greater level, right? So that's the concept behind that way. That's what theta is 90 there in this case, right? So you'll be asked to find B, which is what there it says. It says, where is it there? what are the magnitude and direction of the magnetic field, and that's B. So you're asked to find the value of B, right? So that's how it works, please. Yeah. See you guys in next class. This is your first time here. Do what to like this video, subscribe to this channel, and also share to your friends and classmates that can learn too. I also have several WhatsApp groups you can join, right? So check the description. You see the link to my WhatsApp group. You can join my WhatsApp group and also join my community. Also, I have several courses on my website. So you can visit my website at www.permeability.com. You can see that on the screen, right? Or perhaps you want a one-on-one consultation with me, or want to have any question, just feel free. Reach out to me on my WhatsApp number is displayed upon this video here. So see you guys in the next class, and also welcome to Excellent Link Academy. See you guys in our next tutorial video. All right.
Before we continue this lesson, I want to share something that will make your learning experience even better. I now have exclusive channel memberships designed to help you learn faster, get direct support, and access premium content you won't find in my regular videos. The first level is the support membership. If you enjoy my lessons and want to support the channel while getting special perks, this is for you. It's a simple way to show appreciation and help me continue creating high-quality educational content. The second level is the WAC and JAM classes membership. If you're preparing for WAC or JAM, this membership gives you structured lessons, practice questions, exam strategies, and step-by-step guidance to boost your performance. The third level is the 100-level students membership. This is perfect for secondary school students who want organized, easy-to-understand lessons in physics, chemistry, mathematics, and other subjects. And finally, we have the YouTube Mastery membership. If you want to learn how to grow on YouTube, how to create content, edit videos, design thumbnails, and monetize your channel, this membership will guide you from beginner to creator. Whatever stage you are in, there's a membership designed to help you learn smarter, improve faster, and stay ahead. To join, simply click the membership link in the video description. Choose the level that matches your goals and start enjoying all the exclusive benefits. Hold on, before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of The Shortcut to Academic Success today. Your future self will thank you.